Alright class, thanks for watching the video. I hope you're doing well. I hope your time at home has been good. I know it's weird. I can't wait for all this to be over and to get back in the classroom. When you guys come back next year, I hope you guys stop by and say hello. In this video, we're going to talk about graphing parabolas from vertex form. Alright? So our essential question, how do I graph a quadratic function when it's in vertex form? And it's actually probably the easiest way to graph a parabola. It's really quick and easy once you get the hang of it. So I'm going to show you how we do that. All right, here we go. So first of all, I want to make sure we understand there are different forms of a quadratic equation. We started off with standard form, ax squared plus bx plus c. It just tells you how many of each tile we have, right? So we have different terms. So an x squared is like a big square, and we got skinny sticks and then singletons. And then we talked about factored form, and we went from standard form into factored form. In factored form, you can see it's arranged in a rectangle. And then after we did factored form, we talked about how to go from standard form into perfect square form. And you'll notice this is arranged as a perfect square, but there's something missing. It's incomplete. And so it needs one more square, but if we're going to add one more square to make this a perfect square, then we also need to include a negative, and that's why you see the -1 outside here, right? 8 was not enough, we needed 9, but if we're going to make this a 9, then we have to balance that out by subtracting 1. Notice for the rectangle, the length and the width can be different. Here we use our diamond problem to help figure that out. For the perfect square, your length and your width have to be the same. And so how do we figure this out? We take our b value, the 6x, and we split it in half, right? And so we know 6 cut in half is 3 here, and 3x is here. Now how many singletons are we going to need? We take that 3 and we square it, right? It says 3 by 3 square, which is 9, but we don't have 9, we have 8. And that's why we did this whole -1. Okay, all right, so these are the different forms of quadratic equations. Changing the form just changes the way that it looks, but it does not change the value. It's still the same value. The example I like to use is $20. Sometimes you just want a $20 bill. Sometimes you'd rather have 2 $10 bills. And sometimes you want 4 $5 bills. Now, why would you want that? Well, because they each serve different purposes. If you're going to the gym and you don't want to carry a bunch of bills, you just want one bill, then you want a $20. But if you got to pay 2 people, maybe you want 2 $10 bills. So it's easy to split it up. So the same thing's true with quadratic functions. Each form of the quadratic serves a purpose. So that's why we might prefer it in factored form if we're looking for the x-intercepts. We might prefer it in standard form if we're looking for the y-intercepts. We don't really have a purpose yet for this for this perfect square form, and we're going to take a look at that right now. So if you stare at this picture long enough, and maybe you want to pause it, you can see here that factored form tells us the x-intercepts, here at -4 and -2. Standard form tells us the y-intercept here at 8. But what does the perfect square form tell us? Well, there's only 4 points highlighted. We got this one, and this one. And so if you look down at the bottom, as soon as there it goes, you can see here -3, -1. That's our vertex. -3, -1 is our vertex. And in my perfect square form, I see x plus 3 squared minus 1. I see that same 3 and 1 in my perfect square form. And so perfect square form tells us the vertex. And because it quickly tells us the vertex, we more commonly refer to perfect square form as vertex form. It just makes sense, right? You want to know the vertex, put it in vertex form. And so the vertex is at h and k. So if we look back here, our h value, that's the 3. The k value is -1. But you'll see here, it's not at 3, it's actually at -3. Just like our x-intercept is not actually at 4, it's at -4. It's not at 2, it's at -2. And so in perfect square form or vertex form, the h value is not 3, it's at -3. Our k value stays the same though. So it's at -3, -1. So I want to make sure you note the h value is the opposite. That's why we use an x minus h in the parentheses there, okay? All right, so here's a few examples for you. X minus 2 squared plus 3. So what's the opposite of negative 2? It's positive 2. So my vertex is positive 2, positive 3. All right? My vertex here is the opposite of negative 5, so 5 and 8. 5 comma 8. Here, negative 9, opposite of negative 9 is positive 9. 9, negative 1. All right? The opposite of positive 4 is negative 4. So negative 4 comma 6. Here, negative 3, negative 7. So notice the H value is the opposite. The K value stays the same. That doesn't change at all. Okay? So, you try it out. Why don't you pause the video, identify the vertex in these 4 functions. I'll give you the answers here once you press play. Alright, I hope you actually did press pause and try this on your own. Here's some answers to check your work. How did you do? I hope you did well. Okay, so now that we know the vertex, how do we get to graphing? Because we go back to our essential question. It's on graphing the parabola. Okay, once we know the vertex, the rest is really easy. We just follow the squaring pattern. So what's the squaring pattern? Well, from the vertex, if you go 1 unit in either direction, left or right, you're going to go up 1 squared. What makes it a parabola, what makes it a quadratic, is the fact that it has an x squared, right? So we're following the squaring pattern. You go over 1, you go up 1 squared, 1 unit. You go over 2, you go up 2 squared, which is 4 units. If you go over 3, you go up 3 squared, which is 9. Right? And so we follow that pattern to create the parabola. And don't forget, parabolas are symmetrical, so what you do on the left side, you're also going to do on the right side. Okay, so here's an example where A is 1. You can follow this video. It pretty much walks you through what I just mentioned. So we know that H and K are the vertex, but what about the A value? Well, you'll notice the A value is going to do a stretch or a shrink. There's a video on the next slide that'll kind of walk you through that as well. It makes it skinny or wide. Lastly, when A is negative, you'll notice when A is negative, it's just going to move things down. It's going to reflect it down like a frown. All right, so here's a summary for you. Vertical stretch or shrink, that's the A value, makes it skinny or wide. If A is negative, that means it reflects over the x-axis. It makes it down like a frown. And then H and K value are your vertex. That's the turnaround point. All right. Now I know I didn't press play on those videos. I'd like you to open up the Google slide and watch those videos. It's really a walkthrough on what we do to graph. Okay. All right. Good luck. I can't wait to see you guys again. Hope you're well. Stay safe. And I'll catch you guys next video.